Today we'll be talking about solving equations, and you've been doing this since at least Algebra 1, if not 8th grade, 7th or 8th grade. So the first thing I do need to note is that Mrs. Black goobered up, and I, for some reason, didn't realize what problem this was. This problem goes with these two, not these two. So draw a little box around that so that you know that these three problems go together. Sorry about that. So equations are different than the expressions we had yesterday. I think I actually had this on your notes yesterday. Expressions will just be strings of terms. Equations will have an equal sign. Remember that expressions, if you have an expression, the directions will say simplify, they are simplified, or evaluated, meaning you will just have a number. Equations are solved, meaning you will end up with something like x equals a number. Okay, so these ones you'll just have a number, like 7. These ones you'll have still an equal sign with a variable and a number. At least that much. Okay, so first, solve the equation. So we have got negative x divided by 3 equals 6. So when I'm looking at that, the first thing I need to figure out is what order of operations I have over here. I have a negative x and I have divided by 3. So when we are solving, we need to do PEMDAS backwards. So the first thing the last thing I would do, if I put a number in here, I would make it like negative 9, and then I would, well, dang it, no, that's not going to work. I would make it negative 9 and then divide it by 3. So the last thing I would do is divide by 3, correct? So when I'm solving, the last thing I would do is the first thing I do. So you do it backwards. So the first thing I'm going to do is multiply by 3. Because this was divided by 3, remember its opposite operation is multiplication. So I end up with negative x equals 6 times 3 is 18. Now how do I get rid of a negative? Well, we divide by negative 1. So x equals 18. Alright, so remember, when you're solving, we need to do PEMDAS backwards. Okay. Let's actually throw another example in here. Oh, there's some more complicated ones on your homework. 12 minus 3 times 2w plus 1 equals 7 minus w minus 7. If you notice a lot of 7s, get used to it. That's my favorite number. Okay, so the first thing, hopefully you remember that when you see a number or a negative sign in front of a set of parentheses, do you remember that you need to distribute that? Okay, since this is a negative sign, we don't have anything there. Oop, sorry, that's my wake up alarm and I'm already awake. When you see just a negative sign, you need to put a 1 there to distribute. So you can distribute the negative 1. So as we work this, we'll bring down the 12. We'll distribute the negative 3. So negative 3 times 2 is negative 6. And there's a w, so we have to include our w. Negative 3 times 1 is negative 3. And then bring down our 7. Then we need to distribute our negative. So negative 1 times w is negative w, and negative 1 times negative 7 is now going to be positive 7. Now we need to combine like terms. Okay, this is a little bit tricky, and hang on, let me get an erasable pen. When you combine like terms, so notice on this side 12 and 3 are like terms. When you combine like terms and they're on the same side, some people still want to do this. We cannot do that because they are both on the same side of the equal sign. Okay? When they are on the same side of the equal sign, you can combine them, but you must just combine them how they say. So 12, skip over this, go to this term and use the sign in front of it, 12 minus 3. So 12 minus 3 is 9. Then keep your negative 6w. Do we have like terms on this side to combine? Yep, the 7's are both numbers without variables, so 7, skip over this, plus 7. 7 plus 7 is 14. So we have 14 minus w. Alright, now notice we have w's on both sides and numbers on both sides. We want to get all of the w's on one side. So since this one has more negatives, and I really don't want any negatives, I'm going to add the 6w to this side. So I have 9, that cancels, equals 14 plus 5w. Now this number, since the w's are over here, I need the numbers over there. So I'm going to subtract 14. So 9 minus 14 is negative 5. So I have 5 equals 5w. Divide by 5. I ran out of room. 5 divided by 5 is negative 1. So w equals negative 1. Negative 1 equals w, or you can switch it to say w equals negative 1. Just trade them on their sides. Remember from geometry, that is the symmetric property, right? Yeah, I think so. That you can switch their sides. Okay, next thing we're going to do is solve for the indicated variable. Now this is a little bit different because you won't end up with just a letter equals a number. You'll end up with a string of things, because since I have two variables and I want to solve for this one, that means I want to get it alone. All the other stuff needs to move to the other side. So to do that, I need to start by getting rid of this 20u. So it is positive, so I'll subtract it to the other side. So negative 5t equals 35 minus 20u. And then I still need the t by itself. It's not by itself yet. It's with a negative 5. And remember, when there's not an operation between them, there's an invisible multiplication. So the opposite of multiplication is division. So I'll divide both sides by negative 5. So I have t equals 35 minus 20u divided by negative 5. Okay, now this is an answer, however it's probably not one MathExcel will accept. MathExcel is always going to want you to simplify as much as possible. Now I notice that all of these can be divided by 5. This is a negative 5. Can they all be divided by negative 5? Yep. So we're going to divide them all by negative 5. So we have t equals 35 divided by negative 5 is negative 7. Negative 20 divided by negative 5 is positive 4. Put the u on there. Negative 5 divided by negative 5 is 1. So I don't even need that. So my final answer is negative 7 plus 4u. And yes, I do need both of those things when I type it into MathExcel. Okay, on this one says solve for g. So in this time, this is the one I want alone. So the first thing I see is that I have a 1/2 here. You can divide by 1/2, but that's kind of yucky. So remember, if you don't want to divide by a fraction, you can multiply by its reciprocal. So we can multiply both sides by 2. So I end up with 2v equals g times t to the third. And remember, I still want g alone, so g right now is times t to the third. Notice there wasn't an operation there. That means it's multiplication. So in order to undo multiplication, I need to divide. So I have 2v divided by t to the third, and that will equal, those two will cancel, that will equal just g. Okay, so g is alone, and I am done. Then this last one goes with these two, not those two, remember. So on this one we're going to solve for x. And this one gets a little bit more crazy, okay? So firstly, what property do you notice here with the parentheses? Hopefully you remember that that's distributive property. So we need to distribute here. So we're going to have cx plus 2c minus 5 equals bx plus 3b. Okay, we want to get x by itself, so we probably need to get both of the x's on the same side. So let's see, there's only one term here, one term here. Okay, so let's move this 3b over here. Okay, now when I rewrite this, cx plus, oh, I wanted that first. I'm going to put my letters in alphabetical order. So negative 3b plus 2c minus 5 equals bx. Okay, since I messed up and made this a plus sign, I just make this a minus sign. It should be subtraction here, but I'm not using erasable pen, so it's not going to be for now. It will be on the next step. Now I want both of my x's on the same side, so I'm going to move this over here now. And the reason why I need both of my x's on the same side is because since there's two terms with x's, I need to factor that out. Okay, so I need to, we need to factor out the x. Okay, now factoring is the opposite of the distributive property. So what I'm basically going to do is kind of do this, but this part backwards. So since both terms have an x, I'm going to put the x out front and leave the b minus c inside. See how that happened? It's kind of like if we were giving it liposuction and the x was the fat, we sucked it out to the front and we left the b and the c alone. Okay. And the reason why we had to do this is because when I solve for x, it's not just solve for x and the stuff that it's multiplied by, it's solved just for x. So I can't have two x's, I can only have one. So I needed to suck the x out to the front so that I have the b and the c here. And then I can divide both sides by b minus c. And then look what happened. Now I have negative 3b plus 2c minus 5 divided by b minus c, and that all equals just one singular x, because those things would cancel. Now, I know you might want to cancel this b and this b, and this c and this c. Don't do that. Don't do that. If you are canceling in division, it has to be, the whole thing has to be multiplied by that to cancel it. These things are super glued together right now, this negative 3 and the b, so in order to cancel the negative 3 and the b, I would need a negative 3 and a b down here. Since this b is not super glued to anything, I can't cancel anything. Oh, and the c, same goes for the c. Since this c is not super glued to a 2, I can't cancel that either. Okay, multi-step equations. So solving multi-step equations just means I'm going to have to move stuff from one side to the other. So I see I have a negative 2c and a 5c, and I need to combine those. This one's negative, and I don't really want it to be negative anymore. So since the opposite of negative is addition, I'm going to add it over there. So I've got 7c minus 9 equals 8. And then I need all my numbers on the opposite side of my letters. It's like a middle school dance. All the letters go on one side, all the numbers on the other side. You remember that? When all the boys were on one side or all the girls were on the other side? Maybe that didn't happen at your middle school. Sure happened at mine. Okay, 8 plus 9 is 17. And then we still need the 7 to go away, so we divide by 7, and I ran out of room. So c equals 17 divided by 7. 17 and 7, can they both divide by anything? No, they're both prime. So that's my final answer. And yes, you might get fractions. You just type them into Math Excel. It'll accept them and say, thank you so much. Because that's the right answer. 2x minus 3 times the quantity x plus 4 equals 8. So hopefully you know by now that we need to distribute here. Bring down the 2x. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. That's supposed to be an 8. Now we need to combine like terms. So which terms over here are the like terms? Well, the terms with that both have a variable, so 2x minus 3x, so if I have 2 and I take away 3, that leaves me with negative 1x. I need to get all my numbers on the other side, so I have minus 12. I need to do the opposite of that, which is add 12. So negative 1x equals 20. And finally divide, so x equals negative 20. And remember, if you're ever not sure if your answer is correct, you can take it and put it back into this equation and do like we did in 1-3 to evaluate it. So you would just, in your calculator, 2 times negative 20 minus 3 times parentheses negative 20 plus 4, hit enter and see if you get 8. All right, on the back. The length of a rectangle is 3 centimeters less than twice its width. Okay, so when this says less, remember that's going to be minus. This says twice, we're going to be multiplying. So 3 centimeters less than twice its width. The perimeter is 24 centimeters. So if I have a rectangle, I can draw it here. I have a rectangle. Woo. The length of a rectangle. Okay, so the width is going to be W, right? And we have L and W and L. So how do I find the perimeter? If you don't remember, the formula for perimeter is 2 times the length plus 2 times the width. So when we do this, we're going to make width W, but then up here it says the length is 3 centimeters less than twice its width. So I need 3 centimeters taken away from twice its width. So how do I get twice its width if width is W? Well, 2W. And then I need to take 3 centimeters away from that. So length is actually going to be 2W plus 3. So if I use this perimeter formula, 2L plus 3W, what can I sub in there? Well, here it told me that the perimeter is 24, so I can replace P with 24. 2 times L. Okay, so right now what's going on, sorry, we needed to replace this stuff because there are 3 variables, and 3 variables is too many. Oh gosh, could you just not see anything I just wrote? I hope you can. So 3 variables is too many, so I need to replace them and try to get it down to only 1 variable because I can only have 1 variable at a time. So replace the P with 24. Can I replace L with anything? Yeah, I can replace it with this. 2W minus 3. And then 3, well, W, and I've already got a W. So who said 3? Good grief. At least I caught it now, and not later. There's only 2 widths. Mrs. Black, look at the picture. 2 widths. Stop doing crazy things. Must have written it because of that. I don't know. So 24 equals 2 times 2, 4W minus 6, plus 2 more sides. I apologize for my mistakes. It is really early. So then we just combine like terms. So I have 24. Over here my like terms are 4W and 2W, so you remember you combine them by doing 4W, skip that, plus 2W, so 4 plus 2, 6W minus 6. Now we solve to get W by itself. We would add 6. So 30 equals 6W, divide by 6, and 5 equals W. Okay, so we know that the perimeter is 24, and our question is what are the dimensions of the rectangle? So I need to know what my length is, and I need to know what my width is. So which one did I just find? Well, that's why I used W for width and L for length, and I should have told you that at the beginning because first thing you do in a word problem is tell what your variables mean. So 5 is my width. 5 what? So go back into the problem and look and see that is centimeters. And then, well, how can I find length? I know width. Oh, I can plug it in right there. So I know that my length equals 2w minus 5. So my length is going to be 2 times 5, remember using parentheses when you sub it in, minus 5. So my length is 10 minus... I am a mess today, I'm sorry. Hopefully you noticed that I messed up here. This is 2w minus 3, not 2w minus 5. So 2w minus 3, 2 times 5 is 10, 10 minus 3, my length is 7. I promise I don't usually make this many mistakes, I'm so sorry. And looking at the word problem, my label is centimeters. Okay, last thing, sometimes, always, or never true. How you do these ones is you have to solve it you have to work the problem as much as you can until you get something that is sometimes, always, or never true. So first we're going to start with distributing. 10x plus 4 equals 10x plus 6. And it looks like I have 10x on both sides, so I'm going to subtract 10x and subtract 10x. So I get 4 equals 6. Does 4 equal 6? No, it does not. Never does it equal 6, so this is never true. Over here I don't have any distributing, but it looks like I've got some like terms to combine. So 6x has a like term with what? 2x, good. So 6x, skip that thing, plus 2x, it's going to give me 8x minus 12. On this side I have 3 is a like term with negative 15, so 3 minus 15 is going to be negative 12 plus 8x. So I make the variables go away so I can just look at numbers because that's easier for me. Does negative 12 equal negative 12? Yep, and it always equals negative 12. So go log on to Math Excel and good luck with your assignment.